Yes, sir.
Okay, so introduction was done. Maulik.
Good evening, sir.
No, sir. There, can you start? No, sir.
Okay, so you can start from your end first, then you can give me uh, to talk. Okay,
Okay, sir.
let's go through. Yeah.
Good evening, everyone. On behalf of the IEEE BCREC Student Branch, in association with the Department of Electronics and Communication Engineering and the Industry Institute Partnership Cell, I warmly welcome you all to today's webinar on Introduction to VLSI and Analog IC Design. We are privileged to have with us Mr. Amit Bar, Senior Analog IC Design Engineer at HCLTech. Mr. Amit Bar is a graduate of Jadavpur University, where he completed his Bachelor of Engineering in Electronics and Telecommunication Engineering with first class distinction. He has more than 3 years of industry experience in analog IC design and is actively working in the domain of power management IC and application specific IC product development. His technical expertise includes working on advanced semiconductor technology nodes such as TSMC 40 nanometer, 65 nanometer, and 130 nanometer CMOS technologies, 180 nanometer low voltage and high voltage BCD technologies, global foundries, 130 nanometer high voltage BCD technologies. Apart from his industry contributions, he also shares valuable technical knowledge through his YouTube channel, that is Amit Bar Analog Circuits YouTube channel. Today's session will cover the fundamental of VLSI, basic of analog IC design, semiconductor industry insights, and career opportunities in analog and VLSI design. We are truly excited to learn from his experience and expertise. Without further delay, I would like to invite Mr. Amit Bar to take over the session. Thank you, sir. Over to you.
So it is a nice words about me. Thanks everybody, especially Maulik and the student of Dr. BCREC Engineering College to having me in this session. So first of all, I will be talking about like your stream, mainly who are in the electrical, electronics or instrumentation engineering. Then we'll be talking about the career path right now and what will be happening, let's say after 10 to 20 years, like the future, and all the parks and everything related to this domain, mainly on the VLSI. As you are from electrical electronics instrumentation background, so I would like to say that so you are in a good position, like by seeing in the current scenarios in the industries. Okay, so you are using your mobile phone, your tablets, small gadgets like let's say your earbud and so on. So everything is like very mini, like small, right? Yeah, in what I can say in volume. So that's all about the VLSI, like very large scale integration, or you can see the IC design, like integrated circuit design. So okay, so I always like to have some demonstration with my pen and paper things. So I'm sharing something. Hopefully you can see those. And in between, if you have any doubts, you can just raise your hand and you can tell me. Okay, something you are not understanding fully, so you can tell me. Hopefully it is visible now. Hello.
Hello.
Hello, is it visible?
No, sir, it is
No,
not.
sir.
Okay, okay,
No,
just a minute. Okay, just a minute. Now,
Yes, sir.
yeah.
Yes, sir. Now it is.
Okay.
Yes.
Okay. So there are two types of mainly two types of electronics engineering, that is called hardware design and another is called IC design. Okay. Now, who are the hardware engineers? The component that is called IC or maybe chip. By using this chip or IC, let's say somebody are making, let's say a PCB of a mobile phone, okay, or maybe PCB of a like an electric heater. So that in those engineers are called hardware design engineer. Okay, so they are working on the PCB level. Okay, so they have their component like physical component like resistance, resistor, capacitor, inductor, MOSFET, and any other chip like let's say triple pipe timer IC, and resistance, capacitance, inductance, and some batteries. Okay, so one engineer is making some design using this physical component. So those engineers are called hardware engineers. Now, who are the IC design engineers? Let's say this triple five timer is like fabricated, right? So that is coming in our market and we are buying triple five timer IC. So those IC who are making those IC is called IC design engineer. That is called integrated circuit. Okay. So that is in the now in the nanoscale integrated circuit. Okay, so that is the main two different thing you need to understand. So honestly speaking, when I was in the bachelor's degree, I don't even know these two. Mainly for the analog IC design, you need to be very specialized. Okay, and across world you will find that most of the engineers in the IC analog IC design at least MTech or master's degree or PhDs. Okay, mostly I'm not talking about everybody, like myself is a bachelor's degree holder, but most of the cases you will find they are masters or PhDs. So it is a specialized branch, analog IC design. Okay, so now in the IC design, what are the domains you will find? So broadly, so you will not find this to any book, in any book. So it is my own conclusions. So in the IC design, or this is also called the VLSI. Okay, so there are mainly two types of VLSI. One is called core analog, another is called digital. Okay, So both are very useful, and nowadays most of the things are going for digital. But honestly speaking, analog will be every time, as long as the earth is living. Okay, as long as, because your voice is analog, your light is analog, so somehow you have to sense, right? Your voice, your light, your pressure, everything. So you need some analog module for sure. But digital, the signal processing is very fast. We can store digital, the information in the digital domain. So prominently, most of the chips consisting of digital modules. Okay, but analog will be always be there, because some digital module is running, there needs some power, right? Let's say we are living, so we have to eat something so that we can gain energies. So similar wise, is it analog or digital, you need some power, right? So for that you need power management IC design. Okay, that is my expertise. Okay, expertise domain. So power is needed everywhere. It could be digital, it could be analog. So if most of the part of your chip is digital, even to run this circuit you need some digital supply, like a power supply, right? Maybe battery. But in the IC design, how do we do? We have a golden battery. Let's say your 5 rupee battery you are buying from the market, and everything. Let's say there are lots of module, thousands of module in this whole chip. So now this module could be run in different voltage, this could be run in different voltage, and so on and so forth. So the power is always be requiring. It could be digital or analog. So that is the main point I want to convey here. So now core analog can be again classified into 2 or 3 parts. One is called normal analog IC design. One is called mixed signal design. And that is called RFIC design. Okay. So I'm not focusing more on the digital part today. So in the core analog design, you will find that in the mixed signal IC, you will be seeing ADCs and DACs, right? Analog to digital converter and digital ADC and DAC. Sorry. And in the RFIC, you will see that power amplifiers, LNA, mixture, and so on. And sometimes in the RFIC, the clock system is also there. So let's say clocking, some clocking parts. Again, it is not from any books. So this is my experience I am sharing. And in the analog part, you will see PMIC design. This is the power management IC. You will find some amplifiers. There are lots of types of amplifiers are there. Another is called oscillator. It could be crystal oscillator, RC oscillator, different types of oscillators are there. And again, this amplifier may be not included in this category, but amplifier is everywhere. In the PMIC, there are lots of amplifiers. In the oscillator itself, there are lots of amplifiers are there. But amplifier is a broad category, so like broad domain, lots of types of amplifiers we are using. So I'm mentioning here. And then it is called clocking. Clocking means, so this sorry. So we can assume this oscillator can become inside clocking domain. Okay. Now another important part is your SARDES. Okay. So these are the major domain. Okay. So honestly speaking, if you are expert in any of these domain, so you are doing remarkable work. Okay. So if you are expert in the PMIC or in the oscillator, lots of oscillators are there. You are expert in the SARDES, lots of block in the SARDES are there. So let's say transmitter, receiver, and so on. CTLA and other blocks are there. So it is actually huge, because in the IC design, it's required so much time to become experienced. Okay, so that you can design on your own. You can design in your like your new architecture, and that could be patentable. That could be published in a research journal. Okay. So yeah, that is the category, and I am experienced in these 2 domain. Okay, like PMIC, amplifiers, and some clocking part. I have basic idea about these things, but not expert. Okay. Okay, now talking about the careers. Okay. So most of the student, you know that in India or across the world, the big giant companies are Texas Instrument. There are lots of are there. I'm mentioning some of those who are generally visited Jadavpur University or some IITs or some good universities in India. Texas, Samsung, okay, Intel, Renesas. There are lots of, okay. So these are the product-based companies. Uh, you can point out some names: Synopsys, uh, maybe Qualcomm, and there are lots of other companies are there. Okay, and talking about the Indian market right now, so there are lots of startup in India right now, and proudly speaking, so there are few semiconductor design companies are there. Obviously, startup. Most of them are service based in Kolkata. Okay, so you can find those names. I'm not sharing right now. So there are 4 5 companies in Kolkata. They are doing great things in the VLSI, mostly in the analog. Talking about the salary range, so it will be good for you to know that if you are a good circuit design engineer, IC design engineer, so you will be paid high. Okay, no problem. It is not necessary you have to be a software engineer in the in Amazon, in the Google, so on. Okay, so in India, most of the product based companies pays very nice. Let's say CTC kind of 35 plus LPA is there. Okay, and a minimum of the product base, for my experience, I have been seeing close to more than 20 LPA. So starting, so you are a, let's say, 23 years of graduate student, you can get a very good salary CTC of 20 LPA for a product based IC design company. It could be more than that, but generally I have been seeing, so Texas used to pay this. When you will be seeing that on the internet as well, or if Texas visited to your campus, you will be seeing that. Like nowadays it could be more than that. Okay, and some of the good startup also pays very high. It could be around 20 LPA. And for the startup company, so there is a slightly different thing. So in the startup, they used to do the servicing to the product based company. So the salary could be for a bachelor degree IC design engineer, it could be, let's say, 6 to 10 LPA. Okay, it is across India. It is across India. It could be Kolkata, could be Bangalore, could be Gurgaon as well. Okay. Okay, so now I'll be stopping to take some question from your end till now. Then I'll be moving the circuit part. Okay, what actually we do. Okay, yeah. If you have any question regarding your career, because I know career is the main thing. You have chosen ECE or ETCE, right? Yeah, because most of the student used to have how much salary I will be getting, what will be the culture of the working, okay, what will be the future. And honestly speaking, again, so if you are an analog engineer, so uh, nowadays most of the things are grabbed by AI. So analog is tough to grab so easily by AI. It will be taking more time. Okay, so that is security on the job is a job as well. Okay, in the analog part. Yeah, yeah. Aniket, yeah, yep,
Good evening, sir.
yeah.
Sir, I have two basic questions about this industries. That what is the career growth in your point of view in the next 10 to 20 years? And the second question is, will there be any manufacturing units coming to our India in a big scale,
See,
like they are
yeah,
in
see,
small scales?
manufacturing and design are totally different thing. Okay, manufacturing is different thing, design is a different thing. Both are critical, but design is the main fundamental things. Okay, fabrication very not easy, but it is costly. But if you don't have any design, what are you going to fabricate, right? So
Yes, sir.
yeah, so design is the main key. Then the last part of the whole cycle of the IC is the fabrication and testing. Okay.
Yes, sir.
So you have to have your own design so that it could be fabricated, then it will be tested. Now, if it is okay, then it could be available on the market like 555 timer IC, or it could be your own IC itself. Let's say your name is Aniket Bandopadhyay, so you can make your own chip, and it could be named as, let's say, let's say 771 IC. You are making new chip, and that could be useful in your, let's say, mobile or automotive industry and so on. So my point is the design is the key. Fabrication is not the fundamental things. Okay.
So, sir, there is any design houses or anything?
Yeah,
That
yeah.
is,
Everywhere there is the Kolkata people is also doing the designs.
so there is a particular design house for the ICs, and they
Yeah,
will give
and
the design.
they are paid so high. Again, I'm telling there are lots of in the queue. There are in the hierarchy who are the design engineers. They are highly recognized and highly paid. There comes layout, DFT, testing, validation. They all are analog engineers or analog VLSI engineers, but their job role is different. The pay is different. Recognition is different. Okay, who are the designers? Let's say, for my experience, Jadavpur University people who are the topper of the Bengal, okay, getting hundreds in mathematics, physics, chemistry in his 12th. So they are getting Texas, getting let's say 36 LPA. But when they are going to join Texas Instrument Bangalore, they are not getting design profile, they are getting validation profile. So now this is how the brain is become wasted. Okay. So the problem is, if you are in the big companies, so getting big crucial role is very difficult. The pay will be handsome, but you will not get the highest position. Okay.
And so, what is the basic qualifications for a designing engineer apart from the electronics that we are basic learning we are doing?
See, you can go through my YouTube channel. I have already mentioned hot topic. See, they will be hiring you as an analog engineer, but they will not provide you that profile. So where you can get those profile? So if you are very good at it, then you will get the design. Otherwise, you have to move from lower company.
Okay, sir.
Okay,
Because in
like
case,
whatever I have seen, like
yeah,
most of my friends are working in the Bangalore, paying so high, but they are doing very lower work, like the
okay,
validation, not lower, but not design. That I wanted to mean. Okay, so design is the crucial part. Again, I'm telling, in the industry across world, only 20-25% people are core design engineers. Apart from that, all are DFT, verification, validation, testing, layout engineers. Okay,
so
physical
that
design
is part of
engineer
the
and so on.
design.
So getting into the design is very tough, and doing real design is very, very tougher.
Thank you, sir.
Yeah. So I am here to clarify everything. So when I was in my graduation, so I don't even know what is the meaning of those. Okay. Like what I wanted to mean, let's say some people are going to TI and getting 36 LPA as a CTC and doing validation. But let's say one student is going some not so much known company, but getting into design and let's say getting 8 LPA. But after 5 years, the boy or the girl who is in the 8 LPA doing the real design, after 5 years or after 10 years, there will be huge difference between the design engineers and the validation engineers. Everything regarding career growth, salary wise, and everything. Okay. Because when you are going in the validation layout part, so there is no patent. You cannot have any opportunity to make this patentable, make this as a research paper and so on. But when you are a design engineer, you are be recognized too high. New design will come up from your mind. It could be patentable, it could be published in good international journals. Okay. Yeah.
Sir, can you name some designing companies also?
There are lots of, you can search. You are smart enough, you are using mobiles from,
But
from
if
your,
you can name some,
you
so
can
we can
search.
say.
Yeah, that is your part. Okay, you
Okay,
have to
okay,
do
sir. Okay,
on your own something. Okay.
okay, sir.
Yeah. There are lots of design company, but they are servicing in Bangalore. Hundreds of company. So when I used to visit my LinkedIn, so in a week, I see every day there is a new, like every week I see a new company in Bangalore. Okay, so so the startup is many more in the Bangalore. Okay, and right now in Kolkata as well, there are 4 or 5 things, and hopefully there are many people who are trying to develop their own servicing or product company within Kolkata. So I know some of those people. Okay, so they are trying for Kolkata people as well. Any other question?
Sir, if you could say what are the things we should focus on so that we can get into a design role rather than some other roles. Like, what are the things
Again,
should we
see,
focus on?
most of the cases in the on-campus thing, they will not mention. It will be design, it will be verification, it will be layout, or whatever. It will be stated at analog engineer or analog design engineer. But when you got that role and go to the industry in the company, so you'll be seeing it is not the design. Okay, most of the cases. And some of the off-campus opportunities, they really mention those. It will be analog IC design, or maybe DFT engineer, or could be layout engineer, could be validation engineer, could be physical design engineer. So you have to check for the off-campus to apply. When you are in the on-campus role, so specifically they doesn't really mention which is the actual role, and most of the students don't know what is the difference things between when he or she got into the industry, and then he or she used to know what is the difference. Okay, I am here
Okay, sir.
to make you understand. So those are different. Okay, very different things, and I know most of you don't know, like till now, till today. Okay, and for who, like what is need to study, then I am sharing. So for your answer, I am sharing again. So which things we need to study for this analog VLSI or any analog hardware role as well. Okay, so basic, you need to know KCL KVL, you know, right? Basic KCL KVL. So that is the part of basic circuit theory and network analysis, right? This paper you have already studied.
Yes.
Yeah. Then uh, signal and system. Third is control engineering or control system. Fourth is your analog 1 and analog 2, like analog electronics or analog circuit 1 and 2. Okay. Then, like here you will find diode, amplifiers, right? Bode plots, stability, and so on. Then comes analog IC design. So yeah, these 5 topics is more than enough for a fresher's position, but you need to be good at it. Okay, not you have to solve for everything. So most of the companies like Texas Instrument, they don't like to write some equations. Okay, they want how much you know intuitively. Okay, what is the meaning of a capacitor, how a capacitor behaves when you give a impulse, step, current or voltage. Okay, so intuitively they want how intuitively you know.
So, like they test our thinking process. That is
Yeah,
what.
thinking process.
Okay.
You don't need to write so many things on the paper by using your pen. As less as you can use your pen and paper, so that will be good. Good. Okay, to get selected. And apart from that, if you are applying off campus, so you need to have a good project. Okay, because nowadays students are very smart, so they are having some guide, okay, and doing some good projects so that their CV can be shortlisted for the written test or the interview. Unless you have a good project, so it is very difficult in the off campus to shortlisted your CV. Okay, so that is the reality. I have mentioned these things on my YouTube channel as well. You can just search it. I think it is around 2 years ago, but all are relevant, okay, till now. So circuit theory, network analysis, signal and system, control engineering, analog circuit 1 and 2, and analog IC design. So here you will be seeing the amplifier design in the IC level, okay, in the IC level. So it will be in the nanometer range, right? It's a 180 nanometer technology you are using, or it could be 65 nanometer you are using. So hopefully you have already familiar with cadence. So give more time on the cadence and try to design and try to understand the design procedure. That is more expected things. Okay, the design procedure is main things. Okay, let's say you have a cadence, you are designing random things that doesn't really so meaningful. But let's say you don't have any tools, but you have design idea how to design, how to start the design, how to end the design, considering every parameter like DC gain, PSRR, common mode rejection, gain, stability, and so on, right? So design procedure is very critical things. Okay, any other question? So these are the topics.
Sir,
Yeah.
sir, on which platforms or sources would you recommend for finding off-campus jobs for these designing roles, apart from LinkedIn?
Apart from LinkedIn, tell again.
Sir, where do we find the jobs for designing roles apart from LinkedIn? Off
No, apart
campus.
from LinkedIn, it is very tough. So you have to visit every company's website. And honestly speaking, the big companies doesn't really hire freshers in the design position. Most of the cases. For the freshers, you have to mostly go for the startup companies. Okay, so there are very less vacancies for the freshers in the big giant companies. Okay.
So, sir, how do we stand out from the crowd? Like, generally,
So
a lot
there are
of
two things. Two things. You could have your mentor, or you have to visit LinkedIn every time.
like even in LinkedIn, like how do we stand out from the hundreds or thousands of applicants that are being submitted every day?
Yeah, that's why that is tough. That's why you need some mentorship or some mentor, some guide. Okay, so that is really needed.
Sir, we need to improve our CV also.
Correct. Then your mentor. So that I am talking now. So nowadays people are smarter. Okay, so they are making online guidance and making their career towards their goal. Okay, so that is the reality. And again, I'm telling, 3 years ago we don't have people like me who are guiding like in this way. Okay, so the things was more tougher 3 years ago, 4 years ago. Okay, Himanshu was not there, Onish Shaha was not there. Okay, you probably had like know them, right? They are
Yes, sir.
popular for GATE, and
Get preparation,
so
yes.
they all are of my friends. Okay, so yeah, that is the reality. So you have the scope, okay, to get into the best career path. I'm like honestly, I'm speaking in this general form. The analog is the one of the top 5 branches, top 5 domain across engineering. Okay, it could be rocket science, it could be in the NASA, it could be anywhere. But in my opinion, analog IC design is among top 5. Okay. Again, honestly speaking, in India, if you have good 10 years, 12 years of experience, you can earn in crores as a CTC. Okay. Some of my close people are doing like that. Okay. That is possible.
And sir, what about internship? Do those matters when we apply for off-campus or yes,
See,
when we apply?
anything you have, anything, so anything you have, you are writing, so you have to justify. And anything you are adding, so it is always be beneficial. That is for sure.
No,
You
like if the internship is not VLSI oriented, then
no, then it will not help you, right?
but
Then it will not help you.
okay, okay.
Let's say you are doing PCB, but we require analog IC. So what is the thing? But it is good for you. You can think twice to switch your career here and there. So that is good for you. Anything you are doing for your career, that is good. But yeah, if you have a aim or any goal setting, then you can work towards that. Okay. And honestly speaking, again, the friends from my university, they are the topper of the Bengal. They are trying to get into analog design, but unfortunately, they select few of them, one or two people. Okay, so that much demand it has. And there are lots of profile in the VLSI, analog design, layout, verification, validation, physical design, DFT. Okay, and in the digital part, you will have RTL design, right? So that kind of positions you have. But ultimately, if you in the semiconductor VLSI industry, it is good. It is obviously good. Rather than having in the consultancy and doing your engineering, you are doing in the banks. Okay. But yes, everybody has his own choice. Okay. Any other question? Then I will be moving forward to the circuit part. I
Sir,
will not, yeah.
sir, do industry people need higher education like MTech or something
See,
for
for
designing
particularly for
those?
analog IC, if you have MTech, it is like plus something you have plus, that I can tell you,
Okay.
but not necessarily you have MTech or a master's degree. But if
Okay.
you have that, it is good. It is very good. Like for analog, because analog is a specialized branch. So if you do your MTech in the VLSI and microelectronics or nano chip design or integrated circuit and system, so it will be good for you. Like anything related to VLSI, it will be good. But again, the competition will be more when you are in the, let's say, any university or any college. Master student is very less, and only one or two people will be get selected. So it is very difficult. And for the masters, I don't know. Other than IITs or NITs, master students is not selected by the Texas Instrument. Okay, even for the Jadavpur University itself. Okay. Like who are the bachelors in the Jadavpur University, they are more preferable to the Texas Instrument. Okay.
They prefer freshers
Yeah,
from BTech degrees.
from BTech. MTech will be the fresher, but they usually not take MTech because the quality of the BTech at Jadavpur University is much higher, right?
Yeah.
Yeah, you have to understand. Like as I am from Jadavpur University, so I know everything related to that. But yes, if you go for analog, mixed signal VLSI, having a master degree related field, so it is good. Because there are lots of companies, not only the Texas, right? There are lots of companies, all are very good. All are very good companies. And in Kolkata, there are lots of companies called HCLTech, Lemon Flip Solutions, Antoric Technologies. Uh, there are few Tegot Technologies that is now under in Global Foundries. Uh, there are few more. I'm forgetting. Signed company. Okay. Yeah. And some few companies will be inaugurated in coming years, as far as I know. Can you tell me some hardware design company in electronics? Anybody in India? Because you are electronic background, so you should know. Huh? Which one?
Sustained technology.
Uh, Cannot hear you properly. Can you type which technology? See, HCL is also a hardware design company. HCL has both hardware as well as the VLSI. There are other company called Hind Rectifiers Limited, Sasken. Yes, Sasken is also a VLSI company. Sasken is also a software company, right? Yeah. So hardware wise, you have a Mahindra, you have a which one is
So
called?
Tata ELXSI.
Yeah, Siemens. Yeah, Qualcomm is
Tata,
also hardware as well as the IC design company.
sir, AMD.
I don't think AMD manufactures hardware. Like hardware, I'm meaning, let's say AC, fridge, that kind of things. Okay, that PCB level. AMD is mainly on the chip, right? Chip level. I
Yes, sir.
don't know. Maybe
Designing chip.
it could be. It could be. I don't know.
Then NVIDIA is there for
Nvidia.
manufacturing. And I think, sir,
Intel.
Tata, I was searching Tata ELXSI
Yeah, yeah.
design.
Tata Electronics itself. Okay.
Yeah, Tata Electronics itself is a designing
So
company.
now
And
most of the people who are giant, so everybody will be moving towards VLSI. Okay, after a certain time, and you can see for the Tata itself, right? So whoever the giant company, so they will be moving their branches domain towards VLSI or semiconductor. It could be manufacturing, it could be design, it could be anything. Okay. Any other question? Then we will be designing some of the basic things, and KCL cable we have to learn. And honestly speaking, there are some engineers who are working in the industry, in the hardware design or in the IC, not good at solving KCL and KVLs. Up to a moderate to complex circuit, if I give, so they cannot solve. Okay. So honestly speaking, basic things your KCL and KVLs. Okay. So let's give one question. If you don't have any other question to me right now, then let's see who can answer this question first. Okay. So should I?
Yes, sir.
Yes, sir.
Let's solve it. Okay. Basic KCL KVL. It could be, let's say, 12th level. Okay. 12th level. And most of are you from first year or maybe third year, fourth year? Maulik, most of are from?
Sir, first year.
Sir, first year.
Okay. Okay. Let's solve it then. This is 1 volt. This is 1 ohm. This is 2 ampere. Okay. I want what is the current flowing through the resistance. Let's see who answers first. Who knows the answer? You can speak. No problem. Is it a big circuit or a small circuit?
Small circuits. Sir, 1 ampere only, I guess.
1 ampere. Any other answer? 1
1
ampere.
ampere.
1 ampere. Okay. Let's say I am making this one. Then what is the answer? Now let's say the battery is changed from 1 volt to 2 volt. Then what is the current flowing through the resistor?
So 2 amperes.
2 ampere.
2 amps, 2 amps. Okay. So how you are solving? Anybody who are telling 2 ampere, just explain it.
Sir, because the battery is parallel to the resistor, so it will be 2 amps because then V by R, then 2 by 1.
Then what about this current source? It is doing nothing?
Uh, we can use that also, but I
Because
use
this current can flow here and here also, right?
uh,
Then what about 2 ampere?
Sir, from both sides there was 2 amperes. So
For both side?
from each side 2 ampere current was flowing. As this is a 2 ampere source and there was no another uh, resistance or something was provided. So this 2 ampere directly
Okay.
was.
Now, okay. So let's say your answer is correct. So what is the current flowing here? Can you tell me? What is the current through this branch? IX. If you can answer, then you know everything related KCL KVL. Otherwise, you don't know completely. Quick. Basic circuit. This is
Sir, 1 ampere because voltage current divider law and
Maulik is saying 1 ampere. Any other answer? You know everything. Norton, Thevenin's, KCL, KVL, mesh law, like node analysis, everything you can do. Superposition. That means you are not so much confident about this circuit solving, because see, previously I have seen that I've been seeing that it is answered within 1 minute. Now it already more than 1 or 2 minutes. Somebody is saying 1 ampere. Why it is 1 ampere? It is not 1 ampere. Okay, it is actually 2 ampere. Why? You can do superposition. When you do the superposition for the current source, it will be deactivated, correct? So it will be short circuit. Yes or no? Yes.
yes sir.
Then all of this 2 ampere current will be flowing here. Because this is 1 ohm, this is 0 ohm. So all of the current will be flowing here. So that's why I'm making sure I'm not making you anybody like making confidence low. But KCL KVL need to be understood so nicely. So if I remove all those things, so what is the current? So this current will be 2 ampere, this current will be 2 ampere. Okay, if this is 2 volt. Okay, any doubt?
No,
If
sir.
you have any doubt, you can simulate it on any simulator. Okay, so this whole current is flowing through this. Is it correct or not?
Yes sir.
Yes,
Is,
sir.
is it? I could be wrong. Okay, I could be wrong, because the current through the resistance always be the voltage across this resistance over the R. So this current must be 2 ampere. Yes or no? For sure, it is 2 ampere. Correct? Yes or no?
Yes, sir.
So now this current will be okay. So I make a mistake. So it will be 0 ampere. Is it correct?
Yes, sir. Because
Because yeah, this 2 ampere is going here and this 2 ampere is going there. So there should be
yes,
0.
it will be 0 ampere. Yes, sir.
Otherwise, KCL is not satisfying. Okay. So when you do so this kind of mistakes will happen when you are not like ultimately confident about any circuit solving. Okay. Like, see, when I am making you understand, so almost everybody convinced with the answer of 2 ampere, correct? But you have to have your own confidence so that you can tell, sir, it is not correct because the KCL is not satisfying here. Okay, so now let's modify slightly and try to solve it very quickly. Let's say, and when you are comfortable enough, so you can make your own circuit and you can solve yourself. Okay, so let's say same question. Let's say it is 3 volt. Okay, so can you tell me what is the voltage Vx with respect to ground? Let's say it is again 1 ohm. So previously the final answer was 0 ampere. Okay,
0 across the voltage source, right?
the voltage at Vx with respect to ground. That is the question. The voltage is always measured across 2 points, right? Voltage, but I am saying that what is this node potential with respect to this ground? That is 0 volt. How to solve that quickly? Okay, you can solve any method, take your time, but I will be solving within, let's say, few seconds. So that's why I am here, right, today. What is the Vx voltage? Node potential with respect to ground. So whenever somebody is
3
telling
volt.
node potential, that means another node is always ground, right? Yeah, tell Vx
So
is
3 volt.
3 volt. I don't know. I have to solve. I don't know. 2.5 volt, another answer.
Sir, 2.5 volt.
2.5 volt. Okay. Okay. So 2-3 people already have answered. So let's say I am solving. So this is Vx. So I always try to make KCL. Okay. So that is good. So this 2 ampere will be divided in these two, right? So 2 ampere will be equal to Vx by 1 plus Vx minus 3 over 1. So you have a 2 Vx equals 5. That is Vx equal to 2.5. Right?
Yes, sir.
Yeah, this is the answer. So how much time I have taken? Only, let's say, 10 seconds maybe. As because I am not too much speedy in the calculation. If you are too much speedy on the calculation part, so you can solve within 2 seconds. Okay, right? Because I have to write this and solve. I'm not too speedy. Okay, so that is good. Now I'll be doing some MOSFET circuits. So who are the first year student, they might not be comfortable with this. Okay, but let's solve some MOSFET or maybe op-amp circuit. Okay, who are already in the 3rd year, they know op-amp circuit or maybe some diode circuit. So let's say we have a diode. So diode is nothing but a valve, right? On directional current flow, ideally. Can you tell me what is the equation of a diode voltage in terms of diode currents? Anybody? It will be Vt ln Id over ISS, right? Yes,
Yes,
or
sir.
no? What is Vt? Anybody?
Thermal voltage.
Correct. What is the room temperature value? Approximately equal to 25.6
25.
millivolt
25.
at 300 Kelvin. Correct. Okay. 25 or 26? Yeah. And what is ISS? ISS called reverse saturation current. Correct. So
Yes,
actually,
sir.
in the diode, the current can flow both direction. Ideally, ISS is have to be 0, right? But it is not. There is a reverse saturation current in the nanoampere range, right? Or picoampere range. Let's say 10 of picoampere current. right? Or maybe 100 pico. And what is the ID? ID is the forward current flowing from P side to N side. And this current is 0, ID, in the negative side. But there is a reverse saturation current flowing from here to here, right? So that is the one of the model of a diode. So there are lots of model. Most of the practical model is called exponential, right? Yes or no? So if you write this, so there are four models on the diodes. One is ideal, one is exponential, one is piecewise linear, right? Piecewise linear. And another is voltage. Voltage, what is the actual name? Let me, voltage model maybe, yeah. So what is this meaning? Let's understand this, then we'll be solving some circuit. So ideal means you have a voltage IV characteristics of the diode, and ideal means if you have 0, diode is off, and you have a slightly positive VD, then diode is conducting. So that is the ideal model, this one. What is the exponential model? Your current is exponentially rising. So if you rewrite the equation in terms of ID, it will be coming as ISS times e power eta Vt over Vd, right? So eta is ideality factor. Let's say for simplicity, it is 1, okay? And most of the diodes, it is ranging from 1 to 2, I think. I'm forgetting maybe, but 1 to 2 maybe, or maybe maximum 3, okay? So this is the exponential model. And what is piecewise, what is voltage mode model? Voltage model. So if the diode is conducting, it will act as a voltage source. Let's say silicon diode, it is 0.7, okay? So the current is 0 until you have a 0.7, then it will be acting as a voltage source. So it is 0.7. Unless the current is 0, okay? So this is the meaning. When you cross 0.7 volt, the forward voltage VD, then the diode conducts, and the overall circuit, overall diode can be replaced as a voltage source of 0.7. Another model is voltage model. Voltage model is this, and another is called piecewise linear. Means that you have a small resistance here. So if you do that graphically, it will be looking like this. So most of the case, these two are more closer, okay? In the reality, practical cases, it is could be the like process diode, or it could be a physical diode. So can you name any diode number, physical diode you have been working on the PCB, on the breadboard level? Anybody? Any diode?
Sir,
you know?
1 and 7004.
7004. Okay. 1 and 4148, right? So these are some diodes practically available in the Chandni market. You can go to the Kolkata Chandni market, you will find those, okay? Okay, very nice. So before going to solve any diode circuit, I forget to make you understand what is the RC circuit. The basic common question on any interview in the analog. RC circuit, okay? What is RC circuit? How a RC is getting charged? Do you know? Let's say we have a battery here and we have a switch. Let's say it is a 5-volt battery. This is a, or let's say this is 5 actually. This is no R. Let's say R is 0 and C. Can you tell me what will be the output waveform with respect to time? Anybody? When the switch is closing? Let's say T equals 0 plus the switch is getting closed. Anybody can draw the output waveform? Resistance
Linearly
is what
increasing.
will be the output? And let's say capacitor is initially uncharged. So it was 0 volt previously.
Sir, and the means up to what time will it charge?
Uh, tell again, like how the behavior will be. Let's say
Sir, linearly increasing.
this
Yes, sir.
one.
Linearly.
No, no, normally.
No, no,
Yes, yes,
no.
that one.
Which one? Which one is correct? Anybody?
No,
And
voltage.
it was zero before zero, right? It was zero. Anybody? Any other answer? See, at the moment the switch is getting closed, the scenario becomes like this, right or not?
Yes,
Yes.
sir.
Then this voltage is nothing but this voltage, so it will be charging instantaneously. Okay, there is no resistance, so there will be no time delay to charge the capacitor. Understood?
Yes, sir.
This will be right because there is no R, so there is no time delay, there is no RC delay, so the capacitor will be charging instantaneously. Okay, but in the reality you have a PCB traces, or in the IC you have a routing, so it will take some resistive path. It will see some resistive path for sure. Yeah. Now, what do you think your output will be looking like? It will be now exponential, correct?
Yes, sir.
But my question is why exponential? Any answer from your end? Why exponential? Why not this kind of things? Why not this kind of things? Why? Why exponential? And why not this? Anybody? Do you know? Why exponential? You have to. Okay, so whoever present on the summer internship at Jadavpur University, they should tell this one. Anybody? Okay, so if you solve this circuit by KCL KVL, you will find it will be a first order differential equation. Okay, yes or no?
Yes, sir.
When you solve
Yes,
for
sir.
the V out, you will see that it will be a first order differential equation like this. So A, okay, kind of things. So you know the solution. Okay, so it will be like this. Okay, so you will see that the solution for a first order differential always be exponential. Yes or no? You have solved mathematics so many times in your 12th
Yes,
standard.
sir.
Yeah. So now if I write the output expression, I'm not deriving it. So it is your job to derive this. The derivation is on the book. Okay, every book it has already mentioned. So V output of time will be nothing but V output. Okay, maybe it is the V in. For this case only, 1 minus e power minus t over RC, correct? So this is the
Yes, sir.
equation. So obviously by seeing the equation we can predict the V output is the function of the time in the exponential nature, right? So that's why the charging of a capacitor, of a real capacitor, or of a RC charging is always be exponential. Now my question is, let's say uh, your input was 5 volt and your output is looking like this. So my question is, let's say it is 4.999 volt, or it is exactly 5 volt, and let's say it is some other volt, let's say 3 volt, 3.125 volts. Okay, so my question is, how much time it will take to reach 5 volt, to reach 4.999 volt, and to reach 2.125 volt? Can you tell? Anybody? Do you know how to find those? You have equation, correct? Anybody who are third year, fourth year student? See, you have equation, and let's say your RC value is you need RC value, correct? Let's say 1 second. Okay. Anybody you are doing? Are you solving? Anybody?
Yes, sir. Sir, what is
Yes,
V
sir.
in?
What is
V in value, V in.
B? Let's say 5 volt. 5 volts.
Okay, sir.
Okay, take your time. So I will not solving so much circuit today. So I will be taking your question. Okay, any question you have, you can just ask me, so that it will be better for your upcoming days. Okay, because circuit solving, it is already in my YouTube. There are lots of people who are making good content. Okay, you can study the basic things I have already told. How to prepare, what is needed to be prepared, what is the market scenarios, okay, what is the scope in future, and everything. If I forget anything, you can just ask me, and I'll be answering as max as possible.
Sir, those question answers can I give?
Those questions.
Sir, sir, the time to reach 3.125 volt was t equal to 0.98 into 10 to the power minus 6 second. मतलब 0.98 microsecond.
Okay, so tell me, what is the 63% of 5? 63% of the 5 volt.
3.15.
3.15 volt.
So it will be taking 1 second to reach 3.125 volt. Okay, it will be taking on time constant. So on time constant takes like makes the circuit up to 63% charging. Okay,
Okay, sir.
so there are 5 time constant to reach almost 99.9%. So my question is, how much time it will take to reach 5 volt completely? Anybody? 10 second, 5 second, 100 second, or infinity second. These 4 options. My question is, how much time the capacitor or the circuit will take to reach the
Sir,
V output
sir,
to exactly 5
sir,
volt?
Sir, it will never reach 5 volt.
It will be
Never reach 5 volt total
correct. So it will
because
be taking infinity time, right, to reach 5 volt.
yes, sir.
But approximately, as a design engineers, as a real circuit engineers, we say that after 5 time constant, it is almost 99.9% charged, right?
Yes, sir.
Yeah.
Yes, sir.
So after 5 seconds, your, let's say, your battery, like your mobile charging, so it will be taking, let's say, your time constant of your charger is, like, you have an adapter, right? So there is a AC to DC converter. So in the AC to DC converter, you have a, let's say, large cap, and the time constant of the overall circuit simplified, it is 1 second. So it will take up to 5 seconds to charge your mobile. Okay, so this is how we can imagine it. So every complex circuit can be treated as a black box, right? And uh, we can comment on this black box how the circuit is doing. Any question you can ask the first year student, because they don't know about maybe circuit, how the circuit things is going. From your neck band to any small, larger electrical vehicles, everything consisting of this ICs, okay? Nowadays, your sensors, right? Every sensors on your doors, calling bells, big gates, everywhere you have circuits like ICs are actually. If you have any question, you can ask. Otherwise, we will be leaving, because we can meet again unofficially. If you need that, Moli can arrange, I hope. Okay.
Sure, sir.
Hmm. Can we? Can you please discuss about other technology like IoT? I don't know much about IoT and embedded, but they are also valuable. But on those thing, if you get into this, so you need some software experience as well and some circuit experience as well. All are good, all good. But I don't have much knowledge. So anything, let's say you are developing this IC, those IC could be useful in on those IoT applications. Okay. So we can call it off at 8:30. Okay, Maulik?
Amit,
Yes, sir.
Yes,
Yeah.
sir.
Amit, this is
Yes, sir.
Triveni.
Yes, Triveni, sir. Yeah.
Good evening.
Good evening, sir.
Yes, it's a very good to interact with you. Thanks to the IEEE student chapter, those who have been arranged these things for the student actually. It's very nice that you have come up with a very good initiative. We have a plan something and long back, but
Yes.
now we have started this initiative for the students specifically the Eastern region students, those who have the very limited access to Jadavpur, because we are the alumni of the Jadavpur. We know how the teachers will be there,
Hmm.
so we can get the access and all these things. But the student, those who are actually in our this city, the tier two cities students, those students are very good, but the limited access and limited connectivity with that, they are lack of something the knowledge.
Hmm.
It's a thanks to you that we have you have made this thing possible, that at least you their students can think about the VLSI industry that we are thinking from the last 15 years actually.
Hmm.
Now as the government has changed, probably they things will change rapidly. I think is my hope actually. And regarding the this IEEE sections, I can say that it's a very good opportunity for us that the branch is doing something. The student branch is very active now.
Yeah, it is
I'll
very good.
thanks. I'll thank first thanks to you, and I'll text thanks to the student members, those who have been give the effort, especially Amit, those who have been given the high impact to make this. Maulik also the key persons that make you connect with the students. So we'll definitely meet again different
Yeah, and
platform.
and that day we can discuss about the circuit design.
Yeah,
Actually,
yeah,
this
sure,
is
sure.
the first introductory to motivate student.
Yes,
Why to choose this analog or maybe VLSI. So
yes, yes. We will discuss this discussions will actually. I have a plan. I will discuss you over phone actually. Okay. So
correct.
we have a plan something. So we have to think about a different way. We have planned. So I'll talk with you regarding this. Anyhow, so thanks again, Amit. It's a very good to meet you again virtually. Sometime we'll definitely meet you in the
Yes, yes,
physically
obviously.
definitely.
Yes.
Okay.
Thank you. Thank
So
you, sir,
thanks again.
for inviting me. Yeah. Thank you.
Yeah,
See
we'll
you.
invite you. We'll invite you in our college sometime when you have been available. Please let me know
Yes,
so
yes.
we can talk with you and particularly, and we have a plan something. So we'll definitely do that thing success for the
Correct.
betterment of the students actually.
Hmm.
Okay. So for that, I'll just conclude all these things from my side because I have another meeting for that,
Hmm.
so I have to leave on that. So this is my thanks to all the students, those who have been attended this particular session. I think hopefully we will be enjoying the session, and later part we will definitely continue this type of sessions regularly. So
Hmm.
be in touch with the IEEE student branch chapter students members, so
And
we will get the things.
yeah, thank you, sir. And again, I can tell you personally. So if you need any help, you can contact me further. So I'll be there for you always. Okay,
Yeah,
regarding
sure,
job
sure, sure.
and
I'll
anything.
contact you. I will contact you. No issue. I'll definitely contact with you. Okay. Thanks.
Thank you, sir. Thank you. Thank you,
All the
everybody.
members. Thanks.
Dia, Maulik, and
Thank you
all
so much,
staff
sir.
as well.
Thank you, sir.
Thank you,
Thank
sir.
you, sir, for this knowledgeable session.
Thanks. Thanks.
Yeah, you can conclude the event and we can.
Correct. We can discuss over mobile. No problem.
Okay. Thank you.
Thank you.
Yes, sir. So, sir, we are calling it off at 8:30.
Yeah, 8:30 or in between. If you have any question, anybody, you can ask me. No problem. Okay. Because the reality you have to understand, because we are human, we have some needs to make our career as well. Okay. Yeah, we are knowledgeable, but doing nothing is not good for you, for for earth as well. Okay, so if you have something, you can contribute to the earth in any way. Okay.
Yes, sir.
And I actually first I clarify on the salary things so that it will be good for you to know what is actually happening in the industry. Okay. Because at this age most of you are looking for the salary, how much salary you will get. Okay. Yeah, but honestly speaking again, so there is huge salary, huge recognition in this field.
All the students are requested to fill the feedback form for certification.
Okay, then I am leaving. Okay, so I don't
Thank you,
think there
sir.
is any question query. Okay, if it is, if you have any question, you can further contact me. No problem. Okay.
Yes, sir. Yes, sir.
Okay. Okay. Thank you, everybody.
Thank you, sir.
Thank you, Triveni sir.
One
Thank you,
thing
Thank
thank you,
you.
just I
sir.
want to mention, Amit, one thing I just want to mention
Hmm.
that I just forget to that we have a digital certificate for you actually. I will definitely send it to you over
Okay. Okay. Thanks.
message. Okay. Thank you.
Okay. Okay.
Thank you.
Thank you, sir. Thank you. Thank you. Bye, bye, everyone. Take
Thank you,
care
sir.
and always learn. Yeah. Thank you.
Okay, sir.
Thank you, sir.
Thank you, sir.
Hello.
Hey Maulik, হ্যালো।
Yes.
তোর কাছে এক্সেল শিটের অ্যাক্সেসটা আছে না?
হ্যাঁ।
ওকে।
Feedback form.
The remaining participants make sure to fill the feedback form. Otherwise, your certification might not be sent over. Okay. If you have filled the Google form, then you could leave.